Hi guys, let me introduce myself. My name is Erina Lara Maharani. You can call me Lara. My ID number is 21029147. Today I will explain about material about polynomial. The first material is calculate the value of a polynomial. Polynomial is a mathematical statement that involves adding the multiplication of the power of one or more variables with coefficient. You could say that a polynomial is an algebraic form with the power of a positive integer variable. The polynomial in x of degree n has the general form n x to the power n plus n minus 1 x to the power n minus 1 plus n minus 2 x to the power n minus 2 plus blank blank plus 2 x to the power 2 plus 1x plus 0 with n minus 1 n minus 2 2 1 and 0 is a real constant n coefficient x to the power n minus 1 coefficient x n minus coefficient x to the power n minus 1 2 coefficient x to the power 2 and so on. 0 is called a fixed term. Next, polynomial value. The polynomial in x of degree n can be written in the form of a function as follows: fx equal n x to the power n plus n minus 1 x to the power n minus 1 plus n minus 2 x to the power n minus 2 plus blank blank plus 2 plus x to the power 2 plus 1 x plus 0. The value of fx for x equals k is fk is value can be determined in two ways, that is, one substitution. Fx equal to x to the power 5 minus 2x to the power 4 plus 3x to the power 3 plus x plus 4x to the power 2 minus 10x plus 3. 4x equal to minus 2, where k element r can be determined by substituting into f minus 2 equal to minus 2 to the power 5 minus 2 times minus 2 to the power 4 plus 3 times minus 2 to the power 3 plus 4 times minus 2 to the power 2 minus 10 times minus 2 plus 3. F minus 2 equals to minus 13.2 minus 13.2 minus 24 plus 16 plus 20 plus 3, and f minus 2 equals minus 49. Next, to scam or card. Let fx equal x to the power 4 minus 4x to the power 2 minus 7x minus 20. 4x equal 5. The first thing to do is to sort the writing from left to right, starting from the highest power. What is written in the card are the coefficient of each degree of the polynomial, like one on the screen. The side arrow indicates the sum of row 1 and row 2, which produce the result now. The side arrow Indeed, multiplying the resulting row by x equal 5 and producing row 2. From this method we get f5 equals to 500. Next material, polynomial division. If fx equal 2x to the power 2 plus 1x plus 0 divided by x minus k, give the equation hx and the remainder of the division as we get the relationship fx equal x minus k times hx plus s. To get the equation hx and the remainder of using two methods, that is 1. Usual division. Division in the usual wise as follow, like one on the screen. Example, find the equation and remainder of division 2x to the power 3 plus 7x to the power 2 minus 5 by x minus 2 with division algorithms. Answer 2x to the power 3 divided by x, result 2x to the power 2. 2x to the power 2 times x, result 2x to the power 3, and 2x to the power 2 times minus 2, result minus 4x to the power 2. Next, the minus 11x to the power 2 times divided by x, result 11x times x, uh, 11x to the power 2 and minus 5, and so on. So the result of the division 2x to the power 3 plus 7x to the power 2 minus 5 by x minus 2 is 2x to the power 2 plus 11x plus 22, and the remainder is 9. Next, two-horner division. Division in this way using a card like one on the screen. Based on the two solutions, the result of the division is obtained hx equal 2x plus 2k plus 1, and the remainder of the division s equal to 2k to the power 2 plus 1k plus 0. Next, material remainder theorem. For example, if fx is divided by x by the equation of hx and the remainder of sx, then we get the relationship fx equal px times hx plus sx. If fx on degree n, px divides degree m by m kecil sama n, dan hx degrees n minus m, sx maksimum degree m minus 1. Example, polynomial xx to the power 3 minus 2x plus 5 divided by x plus 2 as the following remainder s equal fk equals x to the power 3 minus x plus 5, s equal f minus 2 equals x times minus 2 to the power 3 minus 2 times to the power 2 plus 5, s equals to minus 55. Next material factor theorem. Let fx be a polynomial where x minus k is the factor if and only if fx equals 0. The factor theorem can be read as follows. If x minus k is a factor of fx, then fx equals 0. If fx equals 0, then x minus k is a factor of fx. Example, determine the factor of fx equal to x to the power 3 plus 2 to the power 2 minus 5x minus 6, the constant minus 6, as factor consisting or plus minus 1, plus minus 2, plus minus 3, and plus minus 6. With the card method above or the substitution method can be now the value so that fx minus 0. F minus 1 equals to minus 1 to the power 3 plus 2 times minus 1 to the power 2 minus 5 times minus 1 minus 6. X equals to 0. Means this is factor. F1 equals to 1 to the power 3 plus 2 times 1 to the power 2 minus 5 times 1 minus 6 equals to minus x. Means this is not factor. Next, F2 x equals to 2 to the power 3 plus 2 to the power 2 minus 5 times 2 minus 6 x equals to means this is factor. F minus 3 equals to minus 3 to the power 3 plus 2 times minus 3 to the power 2 minus 5 times minus 3 minus 6 equals to 0. Means this is factor. So the factor is x plus 1, x minus 2, and x plus 3. Next, the root of the polynomial equations. X minus k is a factor of fx if and only if k is the root of the equation fx equals 0. If a n x to the power n plus a n minus 1 x to the power n minus 1 plus n minus 2 x to the power n minus 2 plus blank blank plus 2x to the power 2 plus 1 x plus 0 with p not equals to 0 is 0 value of fx, then p is divisor 0. If fx has the root p over q pure fraction with q not equals to 0, then p is the divisor of 0 and q is divisor of 0. The properties of the root of the polynomial. 1. Quadratic equation. If x1 and x2 is root equation x to the power 2 plus bx plus c equals 0, so x1 plus x2 equals to minus b over a. X1 times x2 equals to c over a. 2. Equation to the power of 3. If x1, x2, and x3 is root and equation x to the power 3 plus bx to the power 2 plus cx plus d equals to 0. So x1 plus x2 plus x3 equals to minus b over a. x1 times x2 plus x2 times x3 plus x1 times x3 equals to c over a. x1 times x2 times x3 equals to minus d over a. Example, it is known that the equation of the polynomial x to the power 3 minus 2x to the power 2 plus 5x plus 1 with the roots of x1, x2, and x3. Determine the values a. x1 plus x2 plus x3, b. x1 times x2 plus x2 times x3 plus x1 times x3, c. x1 times x2 times x3. Answer: to solve these problems, we don't need to determine the roots first. Let's just go straight. Determine the coefficient x to the power 3 minus 2x to the power 2 plus 5x plus 1. Then a equals 1, b equals minus 2, c equals 5, and d equals 1. x1 plus x2 plus x3 equals 2 minus b over a equals minus 2 over 1 equals to 2. x1 times x2 plus x2 times x3 plus x1 times x3 equals to c over a equals 5 first equals 5. Next, x1 times x2 times x3 equals minus d over a equals to minus 6 second minus equals to 3. Okay, sorry for my mistake, and thank you for watching my videos. Bye bye.